The heliocentric model, which places the Sun at the center of the solar system, represents a monumental shift in human understanding of the cosmos. It challenged centuries of belief in the geocentric model, where Earth was considered the immovable center of the universe. The journey to this revolutionary idea began in ancient Greece and reached its full realization during the Renaissance, transforming science, philosophy, and religion in its wake. The origins of the heliocentric model can be traced back to the ancient Greek philosopher Aristarchus of Samos. In the 3rd century BCE, Aristarchus proposed that the Earth and other planets revolved around the Sun. His hypothesis was based on his observation of celestial motions, but it failed to gain widespread acceptance due to the dominance of the geocentric model established by philosophers like Aristotle and later Ptolemy. The Ptolemaic system, which placed Earth at the center with the planets and Sun orbiting in complex patterns of epicycles, was highly influential. It aligned with philosophical and religious views of a human-centric universe, reinforcing its position as the prevailing cosmological theory for over a millennium. The heliocentric model was revitalized in the 16th century by the Polish astronomer Nicolaus Copernicus. In his groundbreaking work De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, Copernicus proposed a sun-centered system where Earth and the planets orbited the Sun in circular paths. This theory simplified the understanding of celestial motions and eliminated the need for many of the epicycles required in the Ptolemaic model. However, the implications of this theory were profound. It displaced Earth and humanity from the center of the cosmos, challenging deeply held religious and philosophical beliefs. Despite the theoretical elegance of Copernicus's model, it initially gained limited traction, partly due to a lack of observational evidence and partly because it was seen as a mathematical convenience rather than a description of reality. The heliocentric model gained empirical support through the observations of Galileo Galilei in the early 17th century. Using a telescope, Galileo discovered celestial phenomena that were inconsistent with the geocentric model. He observed the phases of Venus, which demonstrated that Venus orbits the Sun, and the moons of Jupiter, which showed that not all celestial bodies revolve around Earth. Galileo's findings provided compelling evidence for the Copernican model and ignited widespread controversy. His advocacy for the heliocentric theory brought him into conflict with the Catholic Church, leading to his famous trial and condemnation. Despite these challenges, Galileo's work laid the groundwork for further advancements in astronomy. The final confirmation of the heliocentric model came with the work of Johannes Kepler and Isaac Newton. Kepler refined the Copernican model by introducing elliptical orbits, as described in his laws of planetary motion. This modification resolved discrepancies in Copernicus's theory and provided a more accurate representation of celestial mechanics. Newton's law of universal gravitation later provided the theoretical framework explaining why planets orbit the Sun. Newton demonstrated that gravitational forces govern the motion of celestial bodies, unifying terrestrial and celestial mechanics under a single set of laws. Together, the contributions of Kepler and Newton solidified the heliocentric model as the foundation of modern astronomy. The acceptance of the heliocentric model marked a profound transformation in human thought. It shifted humanity's perspective from a geocentric to a cosmocentric worldview, paving the way for the scientific revolution. The model not only redefined our understanding of the solar system but also inspired a broader recognition of the universe's vastness and the interconnectedness of natural laws. This paradigm shift encouraged critical thinking, empirical observation, and a willingness to question long-standing beliefs, laying the intellectual foundation for modern science and philosophy. The heliocentric model remains a testament to humanity's capacity for discovery and the enduring pursuit of truth.